Hi, good morning. Today we are going to discuss on the working stress and stress limit state method. And elastic last class we checked on the experimental determination of elastic constant, the nominal stresses to the normal strain. It is Young's modulus is the normal strain to the y directions and x directions. As per the diagram, we showing that the diagram showing linear directions. That means that the concrete is without any cracks and everything. That is called as Young's modulus and elastic limit. Beyond the elastic limit, it is not in the linear concrete, that is non-linear concrete. In the diagram clearly it is showing that. Next we will see the stress diagrams, typical ductile material. The ductile material is the concrete, we already knows. In this diagram you see we apply the load up to the cracking. That means elastic to the plastic, and concrete is elongation, then yielding and necking, broking. This all called as plastic. Another one is elastic. The two zone is there. One is elastic zone, another one is plastic zone. Elastic zone is the only single is there. That is beyond the elastic zone, it is called as plastic zone. It is called as yielding and necking. This consists this all the methods we are find out the methods of the concrete distress. Working stress method is the modular working stress method. It is based on the modular ratio. It is 19,100 we are find out. The already we discussed on the stress strain curve and the up to elastic limit. The working stress method based on the elastic limit. The permissible stresses ultimate yield stress divided the factor of safety. Factor of and M is the modular ratio. It is 280 by 3 sigma cc. We already knows, we already problem solved that one. It is a problem. It is in the refer 21 table number 81 IS 456 modular ratio. It is given in this tabulation. You see y direction, it is the type of the concrete, and this one, and the working stress method is the service load and ultimate load. The service load is the load applying to the structures, it is called service load. Ultimate load is the maximum loads applied for this one. Working stress design load uh, estimated by structures should be the factor of safety. Design philosophy, the moment shear structures calculated by elastic analysis, not considered for the plastic analysis. The concrete behave only elastic behavior. It is composite structure. By elastic, the permissible stresses which are obtained applying specific safety of material strength design. Factor of safety about 3. Nowadays we are using one point only. Limitation of working stresses, drawbacks. Since the real strength not given in the factor of safety, that's why we are not. Modular ratio is the large number. It is 3. The load factor methods, we are taking the load factor into next 1957. It is the load factor method is come. The ultimate load we are taking in this working stress elastic load. Now it is ultimate load divided by the working load. It is called a load factor. The design philosophy, the strength of the section to the ultimate design loads. That means design resistance greater than the design of effect. That is called as design philosophy of the load factor method. In this method, ultimate principle design strength is this one. Load factor method not included in that deflection and cracking. That is the limitation factor for that. In this method, not take considered for the grip and shrinkage. We know all the grip and shrinkage in the concrete technology we already studied. So in this method, it is not included. That is the limitation. Introduction for the limit state method. It is the next chapter we